Welcome to Electron. What are black holes? Black holes are these mysterious things in space that conjure up the imagination of people. Are they really the portals to another dimension? Are they the portals to a wormhole to another place in the universe? No, they're not that, but there's no less mysterious because of that. Black holes are simply the result of a giant battle in the universe where gravity wins over all the other forces that try to push gravity back. Where does it all start? It starts with gravity beginning to make stars out of large nebulas that are throughout all of the galaxies. When big nebulas in space collapse under the force of gravity into a ball of gas reaching a high enough temperature at the center to start nuclear fusion. This nuclear fusion produces radiation that holds back the collapse of the star, holding gravity at bay. It does so as long as the nuclear fusion continues. But eventually, the nuclear fusion process stops, gravity begins to win again, and pushes the core of the star into what we call a white dwarf. Again, another force stops the collapse. That's called electron degeneracy, and that will hold back gravity as long as the mass of the white dwarf does not exceed 1.4 times the mass of the Sun, also known as the Chandrasekhar limit. But if that limit is breached, if the white dwarf gains enough mass from other sources to exceed that limit, gravity wins again, pushes the battle one step further, and collapses the white dwarf into what we call a neutron star. A neutron star is simply nuclear material pushed together with no space between them into a ball about 12 miles across. 12 miles across, gravity just pushing, but somehow the forces internal to the neutrons and the protons, the quarks, somehow hold back that enormous force of gravity. Imagine the enormous pressure at the center of a neutron star when you have about 1 million cubic centimeters loaded on top of each other, each one of them with a mass of 600 billion kilograms. Imagine the pressure at the center. And yes, they hold back against gravity, unless again, the mass is too large. If the mass of a neutron star exceeds 2.5 times the mass of the Sun, gravity wins once again and begins to push down the neutron star into a smaller and smaller and smaller volume. Eventually, there's no stopping gravity, and the volume goes down to what we call a singularity. An enormous amount of matter pushed down together into a ball no bigger, or even smaller, I should say, than a grain of sand. The density is infinite. Around the region of a black hole like that, because that's called a black hole, there's what we call an event horizon. Time simply stands still at the event horizon, and anything getting near there simply gets pulled in, even light. How big is a black hole? It's a zero volume at the center containing all the mass, an event horizon which will grow in size as more and more mass falls inside a black hole. The distance from the center to the event horizon is about 2 miles for every solar mass. For example, a 10 solar mass black hole has an event horizon of 20 miles. 1,000 solar mass has an event horizon of 2,000 miles. And as it gathers more and more mass, the event horizon grows and it reaches out farther with its gravitational force trying to pull things in. At the center of our own galaxy, there's a black hole that contains at least 5 million times the mass of the Sun. It has swallowed up at least 5 million stars already. And in a galaxy about 60 million light years away from us, in the Virgo cluster, a galaxy called M87, at the very center there's a black hole. It contains the mass of over 5 billion stars the size of the Sun. There's no limit as to how much mass a black hole can gather, and yet the volume of the matter continues to just go down to zero volume. But the gravitational influence is there, so anything coming nearby will simply get pulled in. So black holes can have a tremendous influence on the region around it. You get anywhere near a black hole and you'll never be seen again. So stay away from black holes, look at them from a distance, admire them, but just don't get near them. Because once you get too near, you'll simply become part of a black hole.